In this video, we're going to review repetition statements, which are sometimes called loops. You probably remember that repetition statements are a way of repeating a particular action or sequence of instructions until some condition occurs. Algorithmically, there are two different kinds of loops. A count-controlled loop repeats a specific number of times, which can be counted, hence the name, while an event-controlled loop continues until some condition changes values, causing the loop to terminate. While algorithmically there are two kinds of loops, in Java, there are syntactically four different types of loops. There are while loops, for loops, do while loops, and enhanced for loops. In this course, we're going to master all four syntactic styles of loops and both count-controlled and event-controlled loops. We're going to organize our exploration in this course based on syntax and highlight the algorithms that are appropriate for each syntax style as we explore them. In this video, we're going to focus on while loops, which are the most flexible and general type of loop. You can express any kind of count-controlled or event-controlled loop using a while loop. That means that absolutely any algorithm that you need to write for this course that requires a loop can be written using a while loop. You might prefer to write some loops using different syntax because it saves you time or typing in certain situations. But while loops can be used for absolutely anything. So while loops can be used for count-controlled loops or event-controlled loops. And they can also be used to write loops that read until you reach the end of a file. We'll look at examples of all of those different styles of loops. In Java, the syntax for a while loop looks like this. You include the reserved word while and then parentheses. Inside the parentheses, you'll include a Boolean expression. And remember, Boolean expressions are a combination of variables, literals, relational operators, and Boolean operators that can be combined together to capture the logic of some sort of decision that you might make in a program. After the Boolean expression, you'll need to close out your parentheses, and then you delimit the loop body or sequence of instructions that should be repeated by enclosing those instructions inside curly brackets. The typical steps for every kind of while loop begin with initialization. Some variable will be used inside your Boolean expression to control the loop, and you need to initialize the value of that loop control variable before you encounter the while expression. You might initialize a loop control variable through an assignment statement using the assignment operator. You might initialize the value of a loop control variable using a calculation, so you might use a mathematical or Boolean expression, or you might use file input or output to initialize the value of a loop control variable. Once you've initialized the value of the loop control variable, you'll execute instructions until you encounter the loop condition itself. At this point, you'll evaluate the loop condition, the expression that's inside the parentheses, and determine whether that value is true or false. If the value of the condition is true, then it's time to execute the loop body, which is all of the statements that are enclosed in the curly brackets. Within the loop body, it's important to update the value of the loop control variable so that eventually the condition that controls the loop will change in value and cause the loop to terminate. After you've updated the loop control variable, the loop always returns back up to the top and will evaluate the condition inside the while loop's parentheses again to determine if it's true or false. If it's true, you'll execute the body of the loop again. If it's false, it's time to move on with the rest of the program, and you'll continue on with any statements that follow the while loop's body. This example shows the general syntax of the while loop. Now let's explore how we could use a while loop to make a count-controlled loop. Remember that count-controlled loops repeat an action a specific number of times. So count-controlled loops are great if you know that you want to repeat something 5 times, or if you want to repeat something once for each letter in a string, or if you want to repeat something 1,000 times. Anything where the number of repetition is known before the loop starts executing can be a count-controlled loop. Count-controlled loops are a special case of an event-controlled loop, meaning that they have all the same kind of properties and behaviors as an event-controlled loop, but because they're counting the number of times that a loop body executes, some of the syntax is pretty standard and follows a specific pattern. When you're creating a count-controlled loop, the initialization step always involves setting a counter to an initial value. And almost always, the count controlled loop initializes its loop control variable to 0. Typically, count controlled loops use a loop control expression that looks something like this, while the counter is less than the max value, where the max value is the number of times you want to repeat the loop. So if you'd want to repeat the loop 5 times, you'd say while counter's less than 5. After the loop control expression is tested, you determine whether the result is true or false. As with every while loop, if the loop expression is true, then you want to execute all of the statements inside the loop body. And included in the loop body, you'll want to have a statement that updates the value of the loop controlled variable. You can use one of 2 sets of syntax to do this. First, you can use the traditional mathematical expression by saying counter equals counter plus 1. This indicates that Java should look up the current value of counter and then increase its value by 1, and then finally store the result back into the variable called counter. In Java, you could also carry out this same operation using the shorthand notation counter plus plus. Which simply means you want to increment the value of the counter by 1. So both expressions mean the same thing, just one has slightly less typing. You can use either style of update step in this course. Let's look at a small example. Suppose that we want to write a program that prints out the value of a string literal 4 times. Because we know how many times we want to repeat the loop, we can use a count controlled loop to express our logic for this situation. We'll need to make a loop control variable. I called mine count, and loop control variables are counting up the number of times something executed. So that's always a whole number. You can never execute a loop 4.5 times or 12.3446 times. You always execute a loop a whole number of times. Then we need to initialize the value of the counter. I'm using the traditional initialization of 0. That indicates that so far the loop has executed 0 times. Next, I'm going to write my expression that controls the loop and explains to Java how many times to repeat the loop body. In this case, I want to repeat 4 times, so I'm going to write the expression while count's less than 4. Remember, you always say while count's less than, and then include the maximum number of iterations. I'm going to include all the steps that I want to have repeated inside my loop's body. And in this case, I just want to print out the value of the literal hello. So I included a print statement. And then finally, I want to update the value of my loop control variable to remember the fact that I just printed hello an additional time and to count down the number of executions that I still need to complete. Let's practice typing this program into IntelliJ. In this program, I am going to create my variable count and initialize it to 0. That's my initialization step. And in your notes, I did that as 2 separate steps. You can, of course, combine them together if that makes sense in your algorithm. Next, I'm going to include my loop control step. That's where I use the reserved word while and include my expression. In this case, I want to test to see if my variable called count is less than 4. Then the body of the loop is the steps that I want to repeat. In my program, I wanted to print out the value hello. And then finally, I wanted to update the value of the loop control variable. I'm using the shorthand notation to increment the value of count by 1. Let's run the program and see the output. You can see that the output prints the word hello 4 times. Now, it's very important when you're executing loops to be able to trace through them by hand and predict the computer's output in these types of situations. This will enable you to both design your own algorithm successfully and also to debug or understand code that other people have written. Whenever I'm tracing through a loop by hand, I always make a small table. For each row on the table, I include a variable that appears inside my program. And then I use the row for that particular value to keep track of that variable's value as it changes in the program's execution. Anytime I have a variable whose value is unknown, I always initialize it with a question mark to indicate that I don't really know what value it has initially. And of course, hopefully that will change during the execution of the program. If you have a variable whose value is uninitialized at the beginning and you never initialize it to anything, then you probably didn't need that variable in your program in the first place. Let's look at our example program. In my example program, there's one variable, it's called count. In the code that I wrote in IntelliJ, I immediately initialized the count to the value 0. In the version that's in the class notes, I initially declared the variable count and then waited to the next line to initialize it to 0. If I was tracing the version in your notes, I would start out with count's value as a question mark to indicate that the value is unknown. And then as soon as I executed the line that says count equals 0, I'd update it so that the 0 was recorded. The next thing that happens in the program's execution is that it evaluates the expression count less than 4. So we're going to check to see is count, it's my value that's stored in memory, that's the 0 right now. Is that less than 4? Of course it is. 0 is less than 4. And anytime the expression is true, we're going to execute the entire loop body. I like to keep track of the output from my program in a separate area as I'm tracing through. So in this particular example, I'd add the output hello to my output recording. The next thing that happens in the loop body is that I update the value of count to increase by 1. So the previous value was 0. Adding 1 to that value to increase it will make it 1. Now we're at the bottom of the loop. Anytime you've reached the bottom of the loop, you always have to go to the top and reevaluate the loop condition. So we're going to now check to see if the new value of count 1 is less than 4. And of course it is. It's going to execute the body of the loop again, which causes us to print the value hello, and then increment the value of count. So we need to increase it by 1. It was 1, now it'll be 2. Now we're going to go through and test the loop condition again to check to see if 2 is less than 4. It is, so we're going to execute the body of the loop, print the hello message again, and then we'll increment the value of count to increase it by 1, so the 2 becomes a 3. Now we're going to check the loop condition again. 3 is less than 4, so we're going to execute the loop body. We'll print out the value hello, and then increment the value of count, increasing its value by 1. And now finally, we'll check to see if count is less than 4. And because count is currently equal to 4, that will make the loop condition false. We will not execute the body of the loop in this case. We'll just continue on with the rest of the program. In this case, the program terminates. Now, evaluating loops by hand is really convenient, but there's also a built-in debugger that allows you to trace through program variables easily. The debugger icon is available in IntelliJ next to the play button. It looks like a little bug. In order to trace through a loop successfully using the debugger, it's useful to set something called a breakpoint. Just a point where the program's going to pause. You can set it by clicking over on the left-hand margin of your program where IntelliJ shows the line numbers. So if I want to trace through this particular loop, I would put a breakpoint or a pausing point here on line 5 because that's my initial statement, that's my loop control for this particular loop. Once you have a pausing point or breakpoint set, then you're ready to run the program using the debugger. And I do that by clicking on the little bug symbol. As always, your program will compile and then the debugger will open in the bottom pane of your window. Down at the bottom, it shows variables that are created in your program, and our program contains one variable called count, and it's showing me that currently the value of count is 0. Now I can use the debugger buttons down here at the bottom to control the execution of my program one line at a time. Anytime that I want to start executing a loop, I'm going to press Step Into button, which looks like a little down arrow. That's going to cause the program to execute. So in this case, it shows me that count was 0, and we can intuit that that causes the loop condition to be true. It's highlighted and it's executing the body of the loop. To continue on with the program, we can use the Step Over button. That'll cause the next statement to execute. So it executed the step where it printed hello to the screen. You might wonder where that is. You can find the output by clicking on the console tab over here on the left. You can see that it did print out the value hello. You can toggle back and forth between the console, the output option, and the threads and variables, which shows you the values in memory behind the scenes. Let's click the Step Over option again to execute the statement count plus plus. You can see that currently the value of count is 0. Once I've stepped over that, the value of count is updated so that it's 1. And it shows that both in memory and on the loop control evaluation line. So now it's checking to see if count's less than 4, and it's showing that that is true. I'm going to continue to step over, execute the various lines. Remember, I can go to the console window to show the output. Now I'm getting ready to step over the line that says count plus plus. That's where I'll increment the value of count, which will make it become 2. And you can see that up at the top and again inside the computer's memory. Now I'm executing the loop the 3rd time and then finally the 4th time. You can see that after the loop control value updates to before, it still shows that it's evaluating that loop condition one last time, and it shows that it evaluates to false. At that point, the program will continue on with any statements that are below the while loop. Checking the console output, we can see that the hello message printed 4 times.